going over, it seems like. And since we only have an hour, we probably will be cutting it really close. So we'll get started, and if people trickle in as they go, they trickle in. I'm Brian Byars. I'm a teacher over at DeWitt High School. Our presentation today is focusing on Arduinos and what our students do with it. But we tend to talk more about the entire concept of our course. Some of you have seen us before because I recognize faces. Most of these are new students, if you do recognize us. But let me start by telling you a little bit about our course, and then I'll turn this over to the guys and they can talk to you about their Arduinos and what they do with it. We have a course at DeWitt called the DeWitt Research and Development Lab. It was a brainchild, I guess, of mine about 4 or 5 years ago. As a teacher, I was really frustrated with the way education was headed. We were constantly getting all of the objectives thrown at us, all of the testing thrown at us. And I was noticing that my kids were becoming more and more distant, and that my courses were having less of an impact on my students. DeWitt tends to be a pretty decent school, and seeing kids lose their joy in education, you know, that was something that kind of hurt me. And so I started thinking about what would I change, and did I want to be a teacher, or how did this world work, all those things that teachers in their middle teaching career start thinking about and getting frustrated with. And talking to a few other teachers, we decided, you know what, we're just going to reject everybody else's reality and institute our own. And we kind of started living our lives by that way. And it started with a couple of our teachers forming the DeWitt Creativity Group and the Michigan Creativity Group and the United States Creativity Group. I mean, they went huge. And they came to me and said, listen, we really want you to do something cool too. You know, what would you do if you could do whatever you wanted, if it was your world? And I said, well, you know, this is my paradigm. This is what I think education should look like. And they gave me the push to do it. And I made this course, which is my research development lab. We tend to do lots of crazy, crazy cool stuff. And it's centered around taking a student, having them find their passion, and then pursue it. If you heard Nick Provenzano talk about his genius time, his 2020, I think is what it is, it's a similar concept to that, but we do it over a whole course. And we kind of have a science focus for the most part. We threw out grades, we threw out times, we scrapped everything. We still have a time that my students meet generically in the schedule, but the reality is they come when they want and they work when they want, though really the problem is getting them to stop working. Because we found once we start tapping into students' passion and we latch onto that energy and enthusiasm they have and feed it, that the fires just burn out of control and amazing things happen. And that was one of the things that I really was stuck with looking at. I was looking at our football team. DeWitt has a pretty stellar football team. And those kids would just put in hours upon hours to try to be better football players. I coach 2 sports, and my kids just put forth this tremendous amount of time and energy into that sport. We have a robotics team that I wouldn't say is out of this world, but they're pretty darn good. They go to the World Championships each year. And they're there all day, every day, working on their robotics. And I was like, why can't we do that with education? Why can't I take that energy that these choir kids are doing to prepare for their solos, that they're just so enhanced with? Or our dancers, I'm like, why can't I tap that? And so that's what we started to do. We said, what makes those things good? What's motivating them? And can I steal some of that energy that they're focusing on sports or music or whatever and put it into my classroom? And that's what I've done. And when you, the people behind me talk, you'll see they're part of some of those groups, but they've taken what makes them passionate about that and put it into my world. And so that's what we've done. We've had great results. It's now our 4th year running it. What we'll do is we'll have the people behind me give you a synopsis of what they're working on, what they're doing, because they tell their story way, way better than I do. And then you're gonna go fast. And then we'll spend the last 20 minutes answering your questions and digging deeper, because once you hear them talk, it tends to raise way more questions than it provides answers to. So, without kind of wasting time, Niall, I believe you wanted to go first, right?
Yeah.
So go ahead.
All right, hi, my name is Niall Gans. I joined the DeWitt RDL this year. First year here, it's an amazing class. It gives me a lot of freedom to do what I want to do, unlike most classes at DeWitt. And the Arduinos are my main focus in the class, so I don't have a whole lot. I'm working with like a little pamphlet, like the Dude Step books, and it's amazing how much you can do with them. I didn't even know they existed until this year, actually. Byars was talking about Arduinos, and I thought he was pronouncing some word wrong, but then I looked him up and got a couple of them and started playing them. It's really cool. So, a lot of these guys have really cool Arduino projects they're going to show off. I didn't bring mine, so I can't, unfortunately, but I'm going to let them show off their stuff.
My project this year is a one-handed keyboard. As you can see, this is the first prototype, so it's not that far. The biggest thing I've learned this year is I kind of don't really like programming at all. I'm very mechanical on the robotics team. I'm the head builder, and so I really don't enjoy programming at all. But by doing this, I've actually learned how to do some programming things, especially with just buttons and simple circuits, and it's really quite amazing what you can do. My project is a one-handed keyboard. The idea is someone with some sort of disability, if they only have one hand to type, they can use this, and what they do is they click the buttons on the side, and just like you hold shift, you hold the buttons, and they change all the keys, so then you can type. It's really simple, but no one's really done it or looked at into it. So
Oh, wait, before the next person goes, can somebody give us a synopsis of what Arduinos are? Because, like Niall said, he had never even heard of it, and so I imagine there's people here who have no clue. Sure, go.
I'll give it a shot. My name is Jacob Wozniewski. This is my third year in the DeWitt Research and Development Lab, and actually my second year using Arduinos. What I do mainly is I use the Arduino 2650 Mega board, 2650 Mega with a RAMS 1.4 shield, and I use it to run 3D printers. We have 2 3D printers in the Research and Development Lab, which I've been heading for the past 2 years now, as I said earlier. Basically what Arduino is a company in Italy. It is? Yeah, they're in Italy. And they've created these motherboards which are fairly simple to rearrange or redesign for your own purposes. Now what you do is they have a program created around them in which you can take and you can create several small projects based upon their programming system as well. It's really a dual threat program they have, because as I said earlier, they have the motherboard, they also have their own programming software, which is fairly simple, as Josh was saying earlier, to kind of get the hang of. And then in addition to that, they have the teaching programs with the kits that you buy, which most of the projects we have today that are going to be shown off are from the kits themselves, actually, with a fairly simple Arduino Arduino motherboard and some basic programming done on their programming software.
Good.
So I'm Trevor Murphy, this is Jeffrey Foley, and we have been working on a project where we are creating, using Arduinos, a robot that can play the piano. And basically we wanted, so you upload a song onto a flash drive, plug the flash drive into the Arduino reads it, and then is able to use that information from a sound file to move motors around. This includes like hands and fingers to push down keys to play songs that we plan to have 4 hands in different quadrants of the piano, and they'll be able to play songs that are not just for one person, but duets too.
So this is my first year in DeWitt's RDL. I've kind of been a part of the DeWitt Creativity Group and Michigan Creativity Group that Mr. Byars had mentioned earlier. So I've kind of been around this a little bit. Got to see other RDL presentations and stuff throughout the years as it's grown, and I was very intrigued in it, so I signed up for the class because it was something that I was really interested in. And then when we got the Arduinos in, if we're going to be honest, I was a little bit intimidated by them. It's the first thing that I've ever done with something like this, this kind of mechanism, just how powerful it truly can be in enhancing learning. So it was a really unique experience. I remember when we were just talking about our project and coming up with this idea for the robot that played the piano. Trevor kind of looked at me and he said, I really like piano music, but I don't know how to play the piano. So instead of learning, let's just make a robot that'll do it for us. So it's just unique learning opportunities like that. And the course is kind of centered around trust. And Mr. Byars, he kind of pushes us to outlearn him. His rule is that we have to know more than him about a specific topic about a week into it. So it's kind of cool because he pushes us and lets us fail. And the failure is what helps us succeed in the future, helps us learn on our own. So it's a really unique experience, and it's something that I'm really glad I got involved with. We're still learning, trial and error, going through a huge process of just trying to learn how to make it better, how to advance it. But it's a really cool opportunity to be able to do something like that and not have the fear of a bad grade or of failing or whatever the case may be. So yeah, I'm very grateful to be in it, and I look forward to keep advancing in the future.
Right. I'm Ryan Reddick, and this is Ski, and we're doing an EEG headset which controls stuff through brainwaves. So our goal is to control a quadcopter with nothing but our brainwaves by the end of it. And so far, we just got this parts on Monday, and we've been working with it ever since, working with the program and stuff. But by next week, we should be able to get the data going right to a computer for our brainwaves. And like there are 5 types of brainwaves that we want to be able to do. It can probably do more between the range that it gives you. So there's like alpha, beta, delta, gamma, something else. So yeah, at the very beginning, we were like, let's just do. Byars was like, you guys should do something with the EEG headset. That'd be really cool. So we decided to do it, and we want to start off by getting the data, maybe keeping it on for like a day, seeing what our normal data is, taking the average of the daily value. So, and then we want to put it on an LED and control like the different color variations on an LED with it, and then we have a robot that we built just for it. So that one's fun too. It's a little speed wagon, that's what we call it, and it drifts around corners and stuff. So if we say we relax and think of nothing, we should be able to like turn left, and if we concentrate on something to varying degrees, we should be able to like turn right or go straight.
Yeah, and then we've been using the Arduino, and right now I've been mainly the one programming it. And so like right now we hit a roadblock, but like failure leads to success, so it's a learning process. But yeah.
And the funny thing about this is, Byars actually, he talked about it at the last conference, which we didn't even realize at the point, but he actually knows a lot of the things that we're doing, and he just lets us fail. Sets us up for failure. That's funny.
Wait, Smith. No, you go.
Okay.
You wait.
Okay. I'm Cody Moore. I'm a first-year RDL student. I have 2 projects I'm working on right now. One of them is just a little synthesizer. Use the Arduino to make noises. Funny. I have a little demo here of that. It might be a little difficult to hear, but I just have a piezo speaker and a potentiometer hooked up, and when I press a button, it makes little noises, and I can turn the potentiometer. And so that's the first project. That's just kind of for fun because I like synthesizers and they sound funny. The second project is a sound clock based off of the game Animal Crossing. And so Animal Crossing, it's a game from the Nintendo GameCube, came out in 2002 in America. And what you do, you go around and you collect fish and bugs and you shake trees for fruit and you sell them at Tom Nook's shop. The thing I'm basing off though is when you're walking around, every hour has its own little theme that loops. And so from like 7 a.m. to 7:59 a.m., there's this little song that plays the whole hour. And they're really catchy and nice, and I really like listening to the songs, and I sometimes just listen to them on my phone when I'm going throughout my day. So, wouldn't it be great if my whole life was just based on Animal Crossing music? So, what I'm planning to do is use the Arduino to make a little clock interface that I'd put in my house, and it has speakers branching off all over into different rooms and stuff. And I'd be able to play Animal Crossing music in my house. So I wake up at 5 or 6 in the morning, and oh man, I love 6 a.m. And like, cause the theme's playing, and I'm just walking around like I'm so happy right now because I'm listening to Animal Crossing music. And then I get home at like 3 or 4, and then that theme's on. I really like that one too. But the way you can do it is, since I have an SD card hooked up to my Arduino, I could put any theme on there that I wanted. So if I wanted crashing waves at 8 p.m. to kind of wind myself down, then I could just plug that in, loop it for an hour. So that's the second project I'm working on. It's the goal of both projects is to provide happiness for the world, which will consequently change it because everyone will be happy.
Very nice. He hit one of our goals. One of the things that we always strive for is something to change the world. That's one of our main focuses. Sometimes we get astray on that. We have a student right now who has been texting me constantly because I think he made a mess in my lab. And he's just trying to explode stuff. I'm like, you gotta stop exploding stuff, especially if I'm not there. So, sometimes we have to rein people in. You might be wondering, what does this have to do with space? The whole title of our presentation was Arduinos in Space. Like my students, I'm a firm believer in what's good for the goose is good for the gander. What I want them to do is something that I should be doing. And so I try to do that as well. I try to do crazy things and big projects and see how badly I fail. The problem is, as probably many of you know, the energy I have now at 40 is not the same energy level I had when I was 17, especially with life that exists, right? It drives my daughters crazy. We also take projects from people. So you heard Jacob talking about his 3D printers that he built. That was inspired. We had a friend of ours from the Department of Ed who came over and said, I really think you could do a cool class with 3D printers because you have your research and development lab, research what you can do with the printers, like as far as building them from scratch, building them on the cheap, getting it set up into a curriculum that we could take and put it in needy school districts. Could you guys work on that for us? And we were like, well, I never force my kids to do anything in this course, so I said if a group wants to do it, we'll do it. And Waz's group and 2 others were like, yeah, we want to work on that, and that was last year. This summer, I had, well, actually kind of at the end, a teacher approached me and said, you know what, I really think you guys should work on space. Space is a big thing. What the heck are you talking about? And he's an English teacher, and he's like, space is this huge untapped thing, and it's coming back, and there's a maker movement with space, and there's this open source stuff with space. You should space stuff. And I said, okay, I see where you're going with that. And I looked at it for a while, and I went down to Georgia, took a trip down there. My wife was so bitter. It was crazy expensive. I'm like, I got to go. I got to find out. And I went to see Teachers in Space. They were doing a workshop down there. And I was like, hey, can I go to your workshop? And they're like, yeah, come on down. You're doing cool stuff. Come see what we're doing. And they were launching weather balloons to near space. And they were like, why are you here? And I go, well, I want my kids to launch a satellite. Like I said, we don't think little. And so I was like, and they're like, well, that's crazy. That's huge. And I go, right. That's why we want to aim for that. And but the physics teacher down there in Columbus, Georgia, was doing these amazing things with his weather balloons that he was setting up and collecting data. And I learned a ton. And I came back and I started the Michigan Space Program because I don't do little. And I came to my group and I was like, hey, I really want some people to work on me with this Michigan Space Program idea. It's bigger than RDL, but I'd like groups to do this. And you heard nobody's doing space, right? So like even my stuff that I'm like, ooh, I think we should really do this, I don't force people to do it. But I did have some groups who did. And one of the things we started with kind of as our framework is whatever we were going to do, we needed to probably use something little. Something like either a Raspberry Pi or an Arduino or something. And we were looking around at what other people were using. We said, you know what, let's focus on Arduinos. I have no knowledge of Arduinos. All right? It's like I tell them, just dive in and get working on it. And so I talked to some people. I said, guys, let's come up with an experiment to research with our Arduinos. Let's focus on making weather balloons, and let's focus on getting a satellite. And we had 2 or 3 groups who were like, okay, yeah, we'll hit on that. And we had one guy who was like, yeah, I like to do programming. Is there something I can do with that? I'm like, good, you're the head programmer. Yay. And they'll talk about that in a minute. But I was like, so all the programming you have to do. And he's like, oh, great, can you help me? And I go, not even, I didn't even know how to say the name. So the kids laugh at me all the time because I'm like, Arduino, and they just laugh at me. But the reason we want to use Arduino is, do we have an Arduino that I can pick up? It's handy. The red. Let's go red. This is a good one. So this is one that my friend Mr. Smith made. He'll talk about in a second. The thing that's cool about Arduinos and why we wanted them for the space program is, do we have any science teachers in here, sciencey people? Good. Do you recognize, like, not that, this bad boy? Yeah, this is one of those vernier probewares that you got. And if you've ever seen those to use, they're like this big, right? And they're heavy. And when you're trying to send stuff into space, heavy's bad, right? And so I'm like, man, I really want to collect temperature data and pressure data, and it's so much more meaningful when you're dealing with the layers of the atmosphere. If you're not giving them a textbook with all that data points, if they actually pull it up, do it, and have that real-time data and go, oh my gosh, it changes temperature. It's crazy. But I can't send those verniers very well. We have it set up where we can. It's huge. So I said, let's get an Arduino. Notice the difference in size between the Arduino and the vernier that you use. All right? And they can plug it into a battery. That was the part that I just threw around, was the battery coming loose. And what this is Mr. Smith, I'm like, hey, I want you to be able to collect data with this probeware. Figure it out. And this is a shield he bought from Vernier that tags into the Arduino. You can see it stacked onto another one of those red cards. That red card he got that puts everything on an SD card for him. And then this bottom red board is his actual Arduino. When they were talking about the powers of Arduino, that's what they're talking about. That they can take that one little board and start stacking things onto it to make it bigger and better and cooler. So this thing, and we've tested this a multitude of times, now will record data on the SD card for us, whatever sensor we want to program it to do. And the thing that's nice is they can program the sensor to do whatever they want it to do. And that's where it all of a sudden gets powerful, and it's itty-bitty. Right? The thing as a teacher I really like about this, and we haven't gotten into it a lot with our group, but like if you're a science teacher, the way probes like this work is that it's all just voltage, right? And I can actually, when they're programming it, I can't do it, but when they're programming it, I can have them just get the raw voltage. And then they have to take that raw voltage, throw it into a spreadsheet, make it convert it to, say, temperature, and they can actually work through all the conversions. They see the inner workings of what's real. Because so many of our students today, we talk about this in our tech committee meetings a lot, they just think the phone works. Like they don't understand there's a whole bunch of junk going on in the background. We want to make sure they see the background stuff. So anyway, we started doing this for the space program. One of the things we did is we don't tend to do contests very often. One of the things in the course is we believe that we learn to learn, not to learn for a grade, not to learn for a score, not to try to do better on my ACT, not to try to get into college, not to go win the science Olympiad. We're learning because there's value just in knowledge. But we had a group out there, our ArduSat, who sends up cube satellites, and they had a contest, and they said, listen, we'll send your experiment up in our satellite. And we're trying to send a satellite into space. And I said, here's an experiment. Guys, send in an experiment. And they wrote back and said, okay, you're one of 15 groups that we accepted out of colleges, schools, whatever. And Smith will talk about his project, but basically I was like, okay, Smith, I gave him an experiment, and he's like, oh, great, what did you tell him we're going to do? And I'm like, oh, I told him we were going to take readings and stuff. And he's like, well, what do you want? I go, make us an Arduino. Program it to do stuff so it'll fit our experiment. So Smith, go. Floor is yours now. Sorry.
So this is the Arduino that I'm using, and as you can see, there's a lot of wires here. That was one of the hardest parts of having to do it. Is I had background in programming, but all the wiring stuff just was new to me. I didn't know how to solder things or any of that. I actually had to learn how to solder for that board over there. Had to solder one of the shields onto it. But when I did my experiment, I had to learn how to hook each of these sensors up. I have a
electromagnetic sensor and a UV radiation sensor that both hook up to the Arduino, and then the Arduino sends it all to a micro SD card, which records all the data for as long as it's active, and I can have it